So what causes stickiness? Actually, any two materials will stick as long as you can bring them close enough together. For example, these two beakers. If I bring the glass close enough together, there is actually stickiness, there is an attraction, not very much, and I'll tell you why. Because although it looks like this surface is very smooth, it really isn't. If you looked under an electron microscope, you would see all kinds of peaks and valleys. And in order to have stickiness, what we need is for the molecules on one surface to be attracted to those on the other. All molecules have positive and negative areas. So the negative area of one would be attracted to the positive area of the other if we can get them close enough. But we can't do it like this because there are two big peaks and valleys. But we can help by taking one of these and just dipping it in water. Now we have a liquid in between. Now this becomes more sticky because the liquid is attracted to both surfaces. The liquid can flow into all of those little nooks and crevices. But of course I can still pull it apart because the liquid has no rigidity. The liquid doesn't hold together, it can be snapped apart. So what we need in order to stick two surfaces together is a material that can flow over each surface but which can harden. Now one step along that line is chewing gum. Why is chewing gum sticky? Well, it isn't really a liquid, but it does flow. So that when I squeeze it, it can kind of contour into the two surfaces. And because it's a rigid material, it's much harder to pull apart, so it kind of holds my fingers together. But of course, it's still pretty easy to pull my fingers apart because it does not form a real rigid kind of a network. So what we want is a material that has molecules that intertwine with each other, preventing the two surfaces from pulling apart. Now that can be accomplished in many ways. What I've got here is a sugar solution. And you know that sugar is kind of sticky. Why does that become sticky? Because of course the water part of this flows over the two surfaces and the sugar molecules intertwine with each other, holding the two surfaces together. But again, this doesn't happen permanently. If you did the same thing with vinegar, let's say, you wouldn't feel any stickiness at all because the acetic acid molecules that are found in vinegar don't intertwine, don't stick to each other, so you could pull your fingers apart very, very easily. Now, in a glue, what we have is a substance that flows over both surfaces into the contours and then hardens. And when it hardens, then of course the two surfaces cannot be pulled apart. We have all kinds of glues, depending on the kind of surfaces you want to glue together. Crazy glue is an amazing concoction because it is actually composed of very small molecules in solution. The solution flows over the two surfaces, and then upon exposure to the air, it hardens. And it will hold many, many things together with a great deal of rigidity. It can sometimes cause problems. There have been stories of people mistaking crazy glue bottles for medication and even putting it into the eye, if you can imagine that. That requires medical intervention. And then there was a story that comes to us from a pub in Ireland where some vandals put some crazy glue onto the seat of a toilet. A gentleman sat down and they just couldn't pry him off. Eventually they had to remove the whole toilet, take it to the hospital where they used acetone or nail polish remover to dissolve away the glue and unstick the surfaces. So as you can see, the chemistry of stickiness is absolutely fascinating. But if you don't use these things properly, it can lead to a pretty sticky situation.